By now, you're probably familiar with the following formulas. The area of a circle is pi r squared. The area of a triangle is 1/2 the base times the height. Now don't be tricked, because sometimes the height may not be drawn. You may need to find it using Pythagorean theorem. The area of a rectangle or a square is often said length times width, but we'll use base times height, so we use everything the same. Well, what about the area of a parallelogram? So area of a parallelogram. Well, interestingly enough, the area of our parallelogram is going to be very similar to the area of our rectangle. It's going to be the base times the height. And we can actually see this by making this into a composite figure. So if we came over here to this parallelogram and we drew in our height, remember a height is an altitude, we could do the same thing. Whatever is over here, this x amount from there to there, we would actually be able to put it here. And once we do that, this new white figure that we had would look like a rectangle. So the area of a parallelogram is also base times height. But I tell you to proceed with caution. Our height is not the length of one of the sides. Not height. Because if you treat it like a rectangle, where we said many people think of it as length times width, you'll start doing the bottom part times the other side, which is not okay. If we tried to find the area of this parallelogram right now as it was, many of you would say that the area is 5 times 9, or 45 units squared. The problem is that this 5 is not the height. So if we put the height in, remember height forms a right angle. It's an altitude. So if we put that in and we say that that is 3, we would find that using our Pythagorean theorem, 3 squared plus x squared equals 5 squared. We would find that our x squared is 16, and x would have to be 4. Remember, it can't be -4 because we're talking about a distance. So the area of our parallelogram is really 9 times 4, or 36 units squared. When looking at the area of a trapezoid, first we have to realize that we have two bases, base 1 and base 2, and these can be labeled interchangeably either one because they are just given names to differentiate between one and the other. And just like any other polygon, we look at the height, which has to form a right angle, which we'll label H. When we find the area of a trapezoid, we can say that the area formula is 1/2 of base 1 plus base 2 times the height of the trapezoid. Now you might be noticing that we could break this into two triangles and a rectangle, and we could find the area of each one of these 3 pieces and then add them together. We will end up with the same product, the same result if we do this. So let's apply our formula. The area of this trapezoid is equal to 1/2 20 plus 42 times the height of 26. Don't get tricked. The height is not 28 or 35. So the area of our trapezoid is equal to 1/2 of that, so we end up with 806 units squared. Remember, if you're not told what units, they're always units squared. So here are the two problems that you're going to do for homework. Our first one is a regular hexagon, and I'm going to look at this and say, I don't really know how to do this, but I'm going to give you a little hint that I can break this into a rectangle and two triangles. And I'm going to give you a little more information. The height of the triangle is 5. So we have to find the area of the hexagon. And any problem that we do, we can break into figures that are similar to us. So we can break them into circles or semicircles, triangles, and parallelograms. Even trapezoids we can do that with. So find the area of the regular hexagon given to you. Second problem, use the information given to you in the diagram and what you know about our area formulas to find the area of the composite figure.